Yeah, this is where most of our hands-on and experimentation. This is where it happens. This is the grind. This is the table. This is where they see the iron. This is where the servo motors, the panels. This is where the students get to see if their idea is feasible. Because design and design feasibilities are concepts that
Let me Christopher.
you only get them at a higher level, but we're bringing it down in bite sizes for the children, and not just only children, industry professionals, undergrads. When they come here, they have a one-on-one experiment on saying, oh, this thing I'm doing, is it going to work? Okay, I have different means of making sure that they design. So first things first, we train them heavily on hands-on, but we also let them use virtual environments to conceptualize things you cannot just immediately start building. Come on, some of these ideas are capital intensive, but can they simulate a virtual copy, save cost, save time, and if they need to make corrections, make correction on the physical object is longer than just using a mouse and a keyboard to make that adjustment. So we teach them how to do 3D modeling. We also teach them how to do circuit simulation. So instead of actually soldering with the soldering iron physically, they can do the connections virtually, test if that circuit idea is going to work. Then by the time they are putting it physically, it's just straight to deployment. That's cut down that time. So we are teaching them industry scaling mentality from bite sizes. Even when they write code, we have interfaces that's block by block. They don't need to understand all the typing and the syntax. They understand the concept. They use the blocks to make the program. They run them into, for instance, this one here is called Arduino audio block. It's a very simplistic design that we made, courtesy of our partnered company, Mechatron. So they help us in manufacturing this all the way from China, India, all the way from India. And when they bring them here, we test it and we use this in training the students. Sometimes we also send them our designs, they manufacture it and they bring it here. So this now, the students can use it to create a robot that can, like we saw downstairs, the automatic farming and seed planting and harvesting robots. So
what about this? What is this?
okay, this now is another robot that is made for obstacle avoidance. So now we are all talking about autonomous vehicles that will drive themselves. Now, how does that happen? If I stand in front of the vehicle, should vehicle hit me? So now it can detect an obstacle, it can stop. You can even go as far as putting recorded warnings. Please step out of the way or passage. So that even if that person is not aware that he's obstructing a vehicle, he's now made aware. So these are how the students experiment to see if autonomous vehicles are something feasible. And so we also, if you see that arena course down outside on our compound, so if you notice, it's filled with a lot of